Everyone, please welcome Moshiur Khondokar, Director of Engineering with Group M. Thank you very much for being here.
Thank you. Good morning, New York. Before I start my presentation today, I want to see how many of you are DevOps engineer here in the audience. How many of you are a DevOps leader in your organization in the audience? How many of you are into software development or software testing within the audience? Perfect. All right, today I'm here to talk about Group M CI/CD journey. Group M is the largest ad agency in the world, as we are in New York, and we became a CloudBees customer very recently, and CloudBees invited us to talk about our story so that the community and the industry itself can benefit from our lesson. So the way I presented the presentation today is what was the challenges, and what was the solution, and what was the lesson learned in our DevOps or CI/CD journey. With that, I will split the entire presentation in between understanding our problem first, business problem, and then basically going to the solution part of it. So Group M is the largest media company. It's an agency within the agency world. It's within WPP family, and we enable the big businesses and big brand to accomplish their advertising and marketing campaign goals. In terms of the billings, it's pretty high. As you see the number up there. We can brag about every single ad that you see. There is a saying that out of every 3 ads that you can see or view anywhere within any platform, omnichannel platform, one of those ads are served by Group M. So that's the breadth and depth of Group M ad agency. And now I will take a minute to set up the context that our audience, I hope that it will give you context to understand our problem. So as you see, the ad tech domain or ad tech ecosystem, within this ecosystem, it's very complex. There's a lot of data coming in, and we process data, and we export data, and we serve ad. End of the day, it's basically viewing that ad in some platform. We call that impression. So advertiser comes in and comes to the media agency and talk about their media buying plan, talk about their campaign goals, advertising and marketing goals. And through the entire ecosystem, we have data management platform or DMP, we have trading desk, we have verification and measurement area, we have ad server, we have DCO, we have demand side and supply side platform. So there is an advertiser side and there is a publisher side. So end of the day, what it means basically serving that ad, that either it's JavaScript tag or that impression to that specific and targeted audience. So that's pretty much in one line summarize the ad tech 101. So in the next slide, I will talk about M Platform. Basically, the team that I am in is called M Platform, which is part of Group M. We are in-house technology solution for all of the Group M agency. And I will take a minute to walk you through our architecture that we have currently. As you can see, I speak that there are many flow within this architecture. Initially, the data come into our system as a pixel server. Internally, we call them tagger bidder, but it's basically the pixel server that comes into our system. And we have Kafka messaging system that process those messaging. And as you see, we have in AWS in data center, we are migrating our platform from on-prem to cloud infrastructure. But within the architecture flow, you see we have Storm topology as ultimately it's a big data company. We have a lot of data coming into our platform, and we have to process, enhance, model, and segment those data, and ultimately serve it. So within this flow, we have multiple big data piece that is working. We have Hadoop cluster, we have Storm topology, we have Vertica database, we have Galera, MariaDB, And end of the day, to the campaign manager, it's basically MInsight UI down below. But behind the scene, there are multiple complex systems that is working in the backend system. There's big data warehousing team as well, ETL process running. And we are moving towards more into WP IO and WP data vision that WP CTO Stefan has envisioned, and we are moving towards that direction. And Group M CTO Bob Hammond also support, and our organization is supporting that vision with this new architecture, which is more open data initiative. With that, I will come to this point where you see MPID. So essentially, as you might have an Apple phone, iOS device, or Android device, and you see, end of the day, how an advertiser can target you or reach you if they know your data. If somebody knows your data, they can sell you data. So data is the currency of the future. Any organization that owns your data, knows your data, can ultimately advertise and do the marketing of their product. So we call that MPID internally, but this is what we come down to after all of those processing of the data. And the size of the data, as you see within the global insight, we have 50 markets that we collect data and we serve our customer within globally. We have 4 data centers that's geographically distributed in North America, in Virginia, in Germany, it's in Frankfurt. We have Asia Pacific market in Hong Kong, and we have one specifically for China because of their regulation. And we were pretty much an on-prem house until now. As I speak, right now we are moving on-prem to cloud, and strategically we decided to move with Google Cloud, that is our cloud partner. So Group M is migrating their entire code base to Google Cloud. So the volume of data that I was talking about, that essentially it's a big data company. So as you see, we have 8.5 billion events daily that's come into our platform, and there's 255 billion events per month, and we are growing much more. As I said, Open Data Initiative, we're gonna integrate with multiple partner and multiple data partner in that ecosystem. So the challenges that I face, as you see, it's pretty complex. Now, to deliver software with speed, we know the key requirements is people, process, and technology. You can take any technology and implement in your organization if you have right set of people and that right culture within your organization. So to implement the process and accomplish that technology goal, we have to have the people piece of it. That is the key aspect of this entire thing. And there's a famous saying that I personally like called engineering is easy, people are hard. And this quote is taken from a book called Team Geek. So when we are trying to accomplish this goal, that delivering software with quality faster enough, and that's where this whole mindset has to change and has to integrate and implement and basically nourish that kind of mindset within the organization. So we came up with this called building quality together. And software development, as you know, it's not one-man show, it's a team sport. So quality is a shared responsibility among product and engineering. So be it business or technology group within the organization, however your organization is set up. So quality has to be by design, and quality is not cheap. There is cost of quality, as you see in the curve. Quality as code, that's where it improves the entire value of your organization, bringing that CI/CD pipeline. And you have to also develop an ownership culture within an organization where everybody is owning their piece and owning product quality. It's not like I tested my part, I have deployed my piece of code, and that piece of code works in my machine, why it's not working in data center. So that's where that ownership culture comes in. And as we see, it's a media organization, it's definitely not a software organization, and we understand the value of investing in technology, and we are moving towards that direction with the right leadership in place. So we're trying to basically implement the best software engineering practices, And for that, we did some SWOT analysis, basically strength, weakness, and opportunity and threat analysis. So within that curve, we are actually crawling, and we probably want to walk, very soon. And then in some time, we'll run and fly as we go. So within the CI/CD pipeline, the main thing is basically doing that testing. And this is not a new pyramid that I discovered. This is very known within the industry, within the community, that level of testing. So the level of testing starts with unit test, component level integration, and API, and ultimately UI testing. And as the speed is needed to support the business to win in their area, this agile testing model is very known within the industry. So most of the companies already have gone through that, agile transformation, or basically being agile, being fast enough to deliver software. Within that quadrant, there are multiple of testing that you see on the left, on the right. It's basically going through multiple bucket of testing and responsibility. When we talk about that, it has to be, quality is not an afterthought. It should be an integral part of the whole journey. So that's why this shift left testing, where a developer or a QA individual, basically the engineering organization, participate earlier in the iteration of the software delivery or software development process, SDLC process. So that's what we call shift left testing. Within shift left testing, quality has to be as a code. And as I mentioned, quality is not an afterthought. It has to be part of the whole design, quality as code. With those challenges in mind, this is what Group M or M platform we designed. We started with open source version of CI tool Jenkins, and Jenkins being out there, most of the developer knows this, and it was already within the organization that people are familiar with. So we started working with some of the tool over here that you see. We already have our GitHub repo. We started working with Jenkins as our CI tool. Within Jenkins itself, we did a lot of POC, proof of concept. We are moving from monolith to microservice area, so we took a microservice and we did a proof of concept with deploying that microservice in on-prem and also in cloud. And also, we use Jenkins being the sole contributor and sole controller of this whole CI/CD. So we had to have a Jenkins file, we have to have a Docker file and kubeconfig file that I'm going to show you in a minute. But within this workflow, that what you see is basically source code coming into a build tool, where as a continuous integration tool, we use Jenkins. And within Jenkins, we used some, after the build is done, we use some unit test. And after pass and failure, based on the test results, we move into the next level, where we see the code quality, SonarQube. So within code quality, this was a journey for us, actually, to implement SonarQubes and to help onboard other teams. So people, or the team, wanted to be very much comfortable when they're moving to that direction, because with this, you can see a lot of metrics. And I would say within audience, there might be a lot of opinion, but ultimately it's not to show how bad code a developer is writing. It's more of to making sure that that developer is contributing towards that goal, end goal, bringing quality product with faster, faster delivery. So SonarQube shows us the metrics of code quality, code duplication, vulnerability metrics, and also it imposed the best development practice within the organization. So when we brought SonarQube, we saw our code coverage metrics, and our developer were not comfortable. But like I said, our CTO confirmed that our end goal is quality. So we are basically scanning through our code health today to go to a state that we are not yet there. So don't look at unit test coverage, don't look at QA automation test coverage, just plug into that SonarQube and see what the metrics looks like. So once in this flow, once we have those metrics, now Jenkins is helping us to build those code and deploy in some Artifactory, be it Nexus, be it JFrog. It happened to be JFrog within the organization, so that's where we deploy. Now, since we are moving from monolith to microservice architecture, we deployed that artifact. We uploaded that in Docker Hub image because we have some microservices running in Docker Swarm, so we uploaded that image into Docker Hub. After that, we have Ansible script. So within this, it basically covers continuous integration part of it. And now the build is ready. Up to this is developer responsibility, this area. After this build is ready now, hand off this build to QA environment, from development environment to QA environment. And there's a notification already sent out in Slack. Now, at this point, Ansible helped us we chose Ansible. There are multiple other tools, Chef, Puppet, SaltLake, so there are a lot of other tools out there, but Ansible helped us to basically deploy that build in multiple environments. In this use case, we deployed that build into a Kubernetes cluster on-prem. Before that, we have again success and failure notification, because if it fails from dev to QA migration or promoting, we stop at that point and we try to debug what's the use case. And as I said, that's where we draw the line of area of ownership. Our developer go back and check their code. Now coming to the QA space, when the build is in QA, the QA take that build and start testing. Within QA realm, there are multiple stage of testing that we do. Initially, we run some smoke test, and then we go with some functional test. We try to add some automation test over there, and we have integration test and end-to-end test and PBT, which is like our version of build verification testing. So we do have some UI test that is automated in the backend. On the API side, we use REST Assured, an open source library, to automate our API. And we send out those report with extend report to our community, like that specific Scrum team. So now, as you see, the build is in the QA, and QA have run through all different stage of testing, and we have satisfactory results. Now we will promote that build to stage environment. Again, it's in Kubernetes cluster on-prem. So once we deploy there, now is the time when we run some performance and load test, and we're going to do some binary check now with security. At the beginning, we had SonarQube to do the source code analysis. Now it's basically binary code analysis. So at this point, we do have an automated Jira ticket created for the TechOps, technical operation. Still, they own this space to take from stage to production. That's where the line is. The entire CI/CD can be automated, but still we need human interaction over there to make a judgment call based on the test results. So who owns this piece? Operations, technical operations teams own this piece if some build has to go to into production environment. And we triggered that, we promote that build, and we go to either in, we had, within the POC, we used Kubernetes cluster in AWS, also Google Cloud. Moving to this, basically whatever I said, from GitHub to all the way to production, from development to QA, testing, and then stage environment to all the way to production. That's the workflow. So this is the concept. Internally, we tried, as I said, we started with a microservice that was built last year for a compliance rule in European Union, which is called GDPR. And for that, we started with on-prem Kubernetes cluster. We didn't have a lot of expertise on Kubernetes at that point of time. Our technical operation itself and the entire engineering organization was going through some learning curve, understanding the container world, understanding cloud technologies. So towards that realm, as I said, the whole magic is done by Jenkins. And over there, you need to have 3 files, which is located in your GitHub repo. So Jenkins file, a Docker file, and kubeconfig file, which is a YAML file within GitHub repo. So this is what we took, and this is how we designed. So that's why you see that the pipeline created, and it's built, and we see the test results. We see the SonarQube graph on the right-hand side. And coming back to the Jenkins file, this is living within the GitHub. And this is where you see the Docker Hub image was created after the build and uploaded. This is where our Artifactory lives. This is how the Kubernetes cluster looks like. That's our Ansible script. This is the UI dashboard of Kubernetes cluster, the default one. This is the Docker Swarm dashboard. And deploying was not enough. We had to monitor our build, our system, our applications. So there are many tools out there, Grafana, Prometheus, but it happened to be Splunk was already used in the organization, so we leveraged Splunk to monitor. Now moving to challenges, like as we did this proof of concept, we kind of learned our lesson. What are the challenges over there that we learned while we were doing a proof of concept? We see this automation is the key factor of continuous integration and continuous deployment. And the ownership piece of it, big power comes with big responsibility. So the team wants their own Jenkins pipeline, own Jenkins job, be it a developer, be it a QA individual, they want their own pipeline. So there's sort of challenges that we had in the engineering side and also operations side. Within engineering organization, our developer, we were not having enough unit test coverage and functional test automation, and of course code quality. Towards that end, we did not have SonarQube integration. The adoption took time, and also standard versioning strategy was not followed across, because it's a geographically distributed engineering team, so it was not followed thoroughly. So in the operations side, we did not have enough expertise on the Kubernetes, so to set up Kubernetes on-prem or in cloud, also deploying those scripts for the deployment, and also access control. Who can own that pipeline? Is it like my customized version of pipeline, or the team owns it? So that's where we see the issue, and also Jenkins has this running out of disk space issue, like this memory issue. So then we started thinking like, we can do it, but then it will take more time. What are the solutions out there? Within this space, we started doing our evaluation with multiple tools and technology. As you see, this pipeline source, build test, artifact storage, and deploy and monitor. That's pretty much the SDLC cycle. Within this, there are multiple vendors. But we wanted to go with the one who is leader, who understands container, who understands cloud, and who can align with our mission and vision of the organization. There are a lot of tools out there. Spinnaker out there is how many of you know Spinnaker? Awesome, it's a great crowd. So Spinnaker, again, it's an open source project from Netflix, and Google itself used Spinnaker. Bamboo is from Atlassian. There are Travis CI, TeamCity, and you see Jenkins, of course, there, and Argo down below, which is from Intuit. AWS has one called Code Pipeline, and there are multiple, Circle CI, all of those. Now, what was in our mind when we were actually doing all of this evaluation? Our mind was, who can support me? Who is resilient enough? Where I have these metrics done, like security, manageability, and scalability, all of these. That's where I can take up this data, because end of the day, it's data, and we are in an industry where it's highly regulated. So we decided, and also we wanted to see with our mission that moving towards cloud and also moving into the container technology, who can support us? And as you see, with cloud native CI/CD or next generation of CI/CD, Tecton is one of the open source from the Knative, Jenkins, Spinnaker, and CloudBees' very own Jenkins X. So we ultimately decided that CloudBees is the solution for Group M CI/CD. CloudBees has multiple tools, but CloudBees really helped us to set up very quickly, to adopt, to onboard the team, and to move into that pipeline, and to deliver faster. Because as an IT organization, as an engineering organization, we want to be fast enough to deliver, to make sure our business, our product folks are happy, our business are not complaining that engineering are slow. So they can accomplish their business goals, and ultimately we are making, it's a win-win situation for product and technology organization. So throughout that whole journey, CloudBees helped to accelerate that adoption process, because we not necessarily have a lot of Jenkins administrator in the organization. We have other priorities that we have to do. There are multiple moving pieces here. We are moving to cloud. We are moving to microservices. We are moving to a container. That's where CloudBees fit very well. As you see, CloudBees has this security and compliance, flexibility and scalability. That means however you want to manage your pipeline per team, per individual, you can do that. So end of the day, it's enabling and empowering the teams to deliver software faster. Because the developer community want to build feature, whereas tester focus is to make sure nothing breaks and there is quality, and operations main focus is stability. So where do we meet? Where is that whole point where this community comes together and say, okay, together we build, we are delivering software with quality. So that's where CloudBees have done a great job, that our team got onboarded with pipeline faster, and it's agile fashion, so giving power back to the team to make sure they have their own pipeline and they can manage. And if they have issue, they can reach out to CloudBees support team. So basically, going back to the team level, as you see, in an agile team environment, we can have independent pipeline per team, per user. And we have learned a lot through that. There is upstream and downstream dependency, complexity increases, so collaboration does help. As you see the architecture flowing from backend to frontend, backend team is complaining that I have tested my component, frontend team is saying that your SLA is not meeting the expectation, API is slow. So that's where the team is now enabled to fail fast, to test often, to move on that direction of like shift left strategy. So CloudBees have done a great job of measuring and optimizing that whole DevOps performance within the organization, and it helped us within our organization to adopt those. And throughout the whole journey, we do have some lesson learned that I want to share with the audience today. Is standard versioning. So there's multiple, Git branch. Where do I start from? Where do I check in the sprint level, in the feature level, in the development level? Or what is your master should do? What is your release should do? Do we have to reinvent wheel? No. We just have to implement the best practices. So everybody understand the standard and everybody just stick to it. So that's more important to be in CI/CD or to take that journey of DevOps transformation. Every build on master is a deployment to production, period. And automation is the key. As I showed you earlier, that what was the challenges? Automation is key factor to make sure this entire CI/CD works for your organization. So enough unit test, functional test, automated, and also deployment script need to be automated. And we need to run load and performance test. And of course, I didn't mention here security, but security is also a very important aspect of it. Security testing during in the stage and pre-production environment, as you see in the integration environment. And every blue-green deployment for all environment. So if it is not blue, we are not deploying to the next, we are not promoting to the next level. We need to do a lot of acceptance testing, and acceptance test, stop broken deployment, eliminate flaky test, and build a culture of continuous deployment. So basically what it tells, the business gives us the requirement. So if we can engage our product organization and the business folks, be it BDD fashion or whatever fashion it might be, but they can contribute to the quality of the product. As I said, the ultimate goal, the entire SDLC team, entire organization owns quality together. It's not particular area, QA responsibility or operation responsibility. Everyone has their own priority and own backlog. So we learned that poor test coverage breaks the build. So we need to increase test coverage. We need to identify the major functionality of our requirement, and we need to add more tests over there. And the last thing that we learned, never roll back, only move forward. With that, I'm almost to the end of my presentation. We can take some question if there is some question from the audience.
Thank you for sharing your story. I was wondering if you could expand on just the last thing you said, which was never roll back, only move forward.
Sure. So the only thing is, if you move forward, that will at least tell you how well your system behaved. If you roll back, you're not going to identify those issues that already happened. So rollback strategy is just to make sure we are failing fast. As I told you, like the entire message here is fail first and learn from it, from the system. If I roll back, I'm not learning. I'm basically going back to my stable version, whatever it is, in that particular environment. So with moving forward, I can identify those issues and I can work towards it. So fail first and learn from the mistakes and basically implement those back into the SDLC lifecycle.
Hi, this is Munia from Bank of America. Thanks for the very informative presentation. One question I have, in one of your slides, you said that the challenges that you've seen, one of these are memory issues in your Jenkins platform. How did you actually fix this? Did moving to Jenkins X help to fix that issue?
Right, thank you. Very good question. So CloudBees core has this scalability and flexibility. So if you have a Jenkins master running in North America, then there will be node running in your EU or APAC data center. So that's how CloudBees enable your team to scale and to basically not block you to go through your pipeline. So that's where CloudBees comes into the picture. With Jenkins, you have to install your node in multiple data center. Now, this another issue comes into the picture, right? For example, China. We have a specific requirement for China. So you need to install that node within that data center. So CloudBees has this auto-scaling that helps us to basically be into that CI/CD pipeline.
Hi, this is Iftakhar Ivan from Millennium. I have a question about your CI/CD platform deployment-wise. Throughout the whole presentation, you mentioned multiple times about testing and the critical part it plays in CI/CD platform-wise, deployment-wise. Now, how did you convince your organization to invest substantial amount or a serious investment in testing? Because I see your pipeline is completely depending on automated testing, and most of the organization testing is really afterthought. I mean, they don't put it part of the engineering team. They don't even put it part of the development cycle. So it's usually, okay, I developed it, throw the ball over the wall, now you go test it. Now, that strategy will not work in this model. So how did you convince it, and what you have done? What was your challenge to move your organization into that direction?
All right, good. Very good question. Thank you. So as you say, within this entire CI/CD pipeline, QA automation is a big piece of it, right? And QA should not be afterthought. Quality should not be afterthought. The way we address this, we said we need to invest in automation. We have to add more tests so that we are confident enough to move that software build from one environment to another environment. So here is the thing, like we said, first of all, we have to have a pipeline and we have to move there. But to make sure that this pipeline really works for us, we need to have multiple quality gates. And as you see, SonarQube is one of the quality gates. Over there, I will have this code coverage matrix, and securities and vulnerability threats. And it's in the source code level, not in the binary level. So making sure that, first of all, I have done with a small team a proof of concept, and then we took out this to entire organization, making sure our developer team or all the agile team understand that if they move out to this area, so we have written our findings, or there was some documentation internally they can follow, what is the problem statement and what they should do. So the bigger value proposition is there. We said ultimate goal is to deliver software faster. Towards that vision, we need to add unit tests. We need to be also compliant with regulations. So security measurement. And then within QA realm, we try to convince our business that this CI/CD will not work. Most of the organization already have continuous integration, I believe, in the crowd. But the biggest piece here is continuous deployment. Whereas many organizations, also including our organization, going from monthly release cycle to weekly release cycle, and to some extent maybe daily. So if we have to come to that point, we have to have a lot of test, a lot of investment into testing realm, into the QA world. So we show the value proposition, ROI, what is the return of our investment if we try to fix those issues earlier in the development iteration, rather fixing those issues in production. As you saw in one of the slides that I had is Bohr curve, which tells basically how much expensive it is for an organization to fix an issue in production. If it is a financial organization, then it might be $1 billion they're losing in production. So instead of fixing that bug or issue in production, we can fix that within development iteration if we have a lot of QA engineers. So for my organization, we had to convince our business to basically invest in this area of automation. So we hired a lot of QA engineers last year, and we are also looking to hire more in this area.